Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. So in this video, I'm going to discuss about what are the various ways of presentation. So in previous video, I discussed regarding tables and then graphs. I discussed the one of the way of presenting the data. So in today video, I'm going to discuss about the diagrams. So that is the other way of presenting presentation. For that, what are the different types of diagrams that and all we will see now. So presenting the data, so the presenting the data should be able to contain different types of diagrams are also available. So actually in previous video I discussed graphs. So graphs means what we're having should be bar chart, pie chart, like line chart, and then histogram, like this. So those are some of the examples of graphs here. So then I can able to discuss what should be the diagram. So what are the different types of diagrams so we are having for presenting the data. So what said previously, the presentation of data should be a method so which can able to people may organize and communicate information using a variety of tools such as tables, graphs, and methods, right? So tables I covered and then graphs I covered, and today I can able to discuss the diagrams. So diagrams is one of the best way can able to represent the data in the visualization. So presentation of data will be of two types, tabular and then visual presentation. So that we, again, this visual presentation is divided into two categories, graphical presentation and diagrammatic presentation. So I in previous video I discussed graphical presentations, and today we are going to discuss about diagrammatic presentation. So the graphs may be of diagram should be of different types. So what should be the bar diagram and then pie diagram, right, and line diagram. So again, this bar diagram is going to be classified into different types, like simple bar, composite bar, and multiple bar. So see, the first one is pie diagram. So it can also be called as a sector diagram. So which can able to presenting the discrete data of the qualitative characteristics such as blood groups and RH factor, age, group, sex, group, and causes of mortality or social group in a population, etc. Right? So the pie diagram is nothing but we should be able to presenting a discrete data of qualitative characteristics. So there should be example blood groups and then RH factor, age group, sex group, and the causes of mortality or social group in population. The frequencies of these groups are going to be shown in the form of circle, and the degrees of angle should able to denote the frequency and the area of the sector. So in while drawing this pie diagram, so each and every some angles we are going to maintain, right? So the degree of the angle able to denote the frequency and then area of the sector, and it also gives some comparative difference at a glance. So normally if I'm going to uh, make a comparison through various charts, so the pie diagram is the best one which can able to make comparative difference in a beautiful way. And the size of each angle is going to be calculated by multiplying the frequency by the total frequency by 360 degrees. So how the angle is going to be calculated is, so the size of each angle is going to be calculated by multiplying the frequency and the total frequency by 360 degrees. So the size of angle is going to be measured by following equation. So that should be the frequency divided by total frequency into 360 degrees. So we can also be called as a degree measure. So the pie diagram is going to be represent the discrete data of qualitative characteristics such as blood groups, RH factor, age group, sex group, causes of mortality, and social group in population. And the frequencies of these groups all the time is going to be represented in the form of circle, and the degree of the angle is going to be denote the frequency and area of the sector. And it also gives the comparative difference at a glance, and the size of each angle is going to be calculated by the following equation. So that should be frequency is going to be divided by total frequency into 360 degrees. So this entire circle is equal to the 100% of the data normally, and this 100% is going to be divided into different sections or different uh, segments. So how to make this? So first we have to draw this circle here and make a center point of the circle and draw the radius and use a protractor to make it as angle of the first slice, pi slice, right? So first what you have to do, you have to draw the circle and make a center of this and calculate the radius and make use of this protractor and divide it into each segment of the pi diagram. Suppose this institution phase is around 62% and room percentage is 7% and board some 10% and books 3% and transportation 8%. So all the time I'm going to be represented in the form of 100% of data. Suppose this is the field collected by this particular institutes or not. So for that they're going to divide this into entire fee into different categories in the form of percentages. So tuition fee see 62 and the room percent is 17%, boarding and books 3%, transportation 8%. So if you calculate the entire thing, so that should be 100%. So 62%, make a line. So it should be divided into 62%. That should be this tuition fee. And some particular 17% I'm represented in the form of room, and 10% for the boat, and 3% is for books, and 8% is for transportation. So I can able to make the different colors also. So in order to make this presentation very beautiful. And so let me take another example like favorite color and frequency. So the blue, yellow, green, red, purple and other. So the frequency should be some 6, 10, 4, 5, 8 and then 7. So I can able to represent the form of 360 degrees. So for that what I have to do? So the frequency by total frequency. So the frequency is how each and every color is blue is 6, for yellow 10 and green 4. Right? So for that, so what should be the total frequency? That should be 40. So how the 40 is coming? So the 60 divided by 40 into 360. So 540. So this should be the 540. So that is 54 degrees. So this should be the 54 degrees for blue. So similarly, I want to calculate what should be the percentage for yellow. So what is the yellow? So 10 divided by 40 into 360. So what should be the angle? 90. So 90 degrees. So 90 degrees I have to draw for the yellow. And for green, so how it will be? 4 by 40 into 360, 9, 36. So 36 degrees. So what should be the green? So I can able to draw a green of angle 36 degrees. So that should be 36. Similarly, if I want to calculate for red, so 5 divided by 40 into 360, 45. So I can write it as 45 here, and this is for red. And purple, So how much it is? 72. So 72 degrees, not right. And next one is 63. And this is for 72 is for purple, and this is for others alone. So like this I can able to partition the entire circle into different segments. So based on this equation, right, I like this I can able to construct the pie diagram by giving this different colors. It makes the pie chart should be very beautiful and all. Let's see the another example. So the following table gives the monthly expenditure of the family. So it is going to be represented by means of pie diagram here. So this is the problem they are giving. So for that what I am doing is I have to create a table of items and then expenditure and degree of measurement I have to calculate it. So how much I have to represent the pie diagram. So first one is food. So expenditure is 1050, and then for clothing expenditure 650, house rent 500, education 350, fuel 200, and others 250. So how can I able to get this? So for that, what is frequency? Suppose 1050 divided by, suppose the sum of this one is around some 4000 something. So into 360 I have to write. So let me take this should be around 3600, so that everything should be cancelled. So 105 degrees. So like this. Similarly, I have to calculate 650 divided by 360 into 360. 650, that should be 65 degrees. And then 500 divided by 360 into 360. 3600, 360. So 50 degrees. So like this I can able to represent. So yellow is the for food, and for this is for clothing, and this is for house rent. I can able to divide into each and every segment into different colors, so that each and every color you can able to print the form of bar diagram. And next one is the bar diagram. So bar diagram consists of a series of rectangular bars of equal width, right? And the bars stand on common baseline with equal gap between one bar to the another bar. And the bars may be in either in horizontal or in vertical. So the bars are going to be constructed in such a way that their lengths are proportional to the magnitudes. That should be nothing but frequency. So the bar diagram consists of series of rectangular bars of equal width, and the bars should stand on common baseline with equal gap between one bar to the another bar, and all the bars should be either in horizontal or in vertical, and these bars are going to be constructed in such a way that the length of proportion should be equal to the magnitude size. Make a note that the space between the consecutive bars should be equal only, and all the bars should be of equal width. So these two things we have to be remembered while drawing bars. So the space between two consecutive bars should also be same, and the bars are all of equal width. So they should be width. So that should be in equal, and the spacing between them should also be equal. So all the bars should be represented either in form of horizontal, and I can also represent in the form of vertical also. So let me take the simple bar. So this bar diagram is divided into different categories. So simple bar, composite bar, multiple bar, like this. So let's see how to construct this simple bar diagram. So for that, so this bar diagram is going to be represent when the items have to be compared with a single characteristics. So when I'm going to draw this bar diagram means, so normally this one is going to be used to represent items which is going to be compared with regard to a single characteristic. So the fruits I'm taking on x-axis here, and number of people also on y-axis. So I would like to know the people who are liking the most nice fruit. I want to find out. So for that, what I have to do? So the items are going to be represented by rectangle bars are of equal width and height also proportional to the magnitude. And the bars what I drawn on a should be on a common baseline with equal distance between two consecutive bars, and the bars may be shaded also. So the items are going to be represented as rectangular bars of equal width and the height proportional to the magnitude. So the bars what I drawn should be on the same baseline with equal distance between consecutive bars, and the bars also be shaded. Suppose I want to find, suppose for people, apple, the number of people liking is 35. For orange it should be 30, and banana some 10, and kiwi it should be around 25, and blueberry it should be 40, and grapes it should be 5. So this is the data what I'm having. So for this I have to construct this bar diagram. So apple how much, so I'm taking all these things that should be fruit names will be on x-axis, and the number of people on a y-axis, right? So apple how much, 35. So I have to draw this rectangle bar of equal width on the 35, and orange should be around 30, right? So for that I'm going to draw corresponding with 30. And next one banana, so banana is around 10, so 10 means up to 10 I have to draw it. And next one kiwi, so 25, so 25 I have to draw it. And then blueberry 40 it is showing, so and then 5. So these are the some of the bar diagrams what I am having in the form of mm, visualization I can able to show. So another example, so the number of ways of children travel to school in the one of the classes. So I want to find out. So transportation to the school I want to find. So for this, so bicycle, 2 people, bus, 3, car, 6, walk by walking, 18, and scooter is nothing, train is nothing. So this is the data what I am having. So for this one, I have to construct the bar graph. So how to construct it? So bicycle. So I'm taking all the vehicles on the x-axis here, and then the number of people I'm taking on y-axis, and I'm going to draw the bar chart like bicycle. So how it is 2. So 2, and then bus. How much, 3. So this should be 3. And next car 6. So 6 I'm drawing, and walk 18, and scooter 0. So that's why I'm not drawing any kind of bar, and train should also be 0. So like this I can able to draw the bar diagram. Similarly I can able to find the number of deaths I want to find out according to the particular disease. Suppose chronic lower representative disease, pneumonia, and cerebrovascular disease and disorder of heart. So how many number of deaths are carried out? I want to make a difference. So for that I have to construct the bar diagram. So for that what I have to do? So and let me take this, and diseases on x-axis, and they should be on y-axis, and construct. So let it be the lower representative disease should be around from 1594. So make a mate of where it is. So 1594 I have to mark it, and like this I have to construct. Similarly pneumonia, so 3263. So let me take this, and like this I have to construct it. So 2175. So 175 and then 6417, and this is also should be so like this I can able to draw this bar chart, simple bar by considering the data and this subdivided, so the component or stacked or proportional bar diagram. So what does that means? So within the single bar itself I can able to classify the data into different categories. Within the bar itself I can able to represent it. So for that, so the data what we're having, so whose magnitude are having two or more components, so this is the bar, right? So within this bar I can able to make different partitions. That should be the stacked bar diagram or component bar diagram or proportional bar diagram. Here also the items are going to be represented by rectangular bars of equal width and the height is also proportional to the magnitude. Then the bars are going to be divided such that the subdivisions in height represent the components, and in order to distinguish the components from one another clearly, so I can able to make the different shades are to be applied, and index describing the shades also provided. So the component bars are drawn when a comparison of total magnitude along the components is required. So if I am going to draw this component bar, so I have to make the comparison of total magnitudes along with the component is required, right? So suppose, so this color, purple color is the blood group of O persons, and blood group of AB is represented through green, and blood group of B should be represented through red, and blood group of blue is going to represent G. So this is the different. So within the single bar I can able to represent so how much it is. So let me show the example. So the example shows the strength of students in nursing degree course. So I want to find out how many number of girls and how many number of boys are there for doing this degree course, like first BSc, second BSc, third BSc, and fourth BSc, right? So I'm taking the degree course on x-axis here, and the number of students or strength of the students I'm taking it as a y-axis. So first I have to find, suppose in first BSc, the boys and girls, so 10, 40 and boys are 10. So within this I have to construct a bar of how much, so total 10 plus 40 how much, 50. So up to 50 I have to rectangle bar. Out of that, so 10% will be the boys, so up to 10 I have to mark it as one color, so that should be related to boys, and 40 or should be girls, right? So 40 remaining color should be 40, so this should be girls of different color. So like this within the bar itself I can able to specify the details in clearly. Similarly I want to find out in second BSc. So in second BSc I want to find, so for that what I have to do, so for that suppose the number of boys should be 7, the number of girls should be 38, so I want to represent it. So for that what I have to do, I have to, what is 7 plus 38, something 45. So up to 45 I have to mark a rectangle, and out of that, so 7 and 38, 7 is for boys, so up to 7 I have to mark it as blue, so they should be boys and remaining should be girls of different colors. So similarly next one is third BSc. I want to find the number of boys should be 6 and girls should be 41, so totally 47. So make a mark of 47 here and draw a rectangle, and represent 6 should be related to boys, so up to make a mark of 6 here, there should be boys, and this should be girls. So like this I can able to represent the bar diagram, or like composite bar diagram. So another one is that percent bar diagram. So the percent bar diagram is nothing but, so within the single bar is I can able to represent the form of percentage also. So first you represent the items whose magnitude is having two or more components, and the comparison of components are going to be expressed as the percentage of corresponding totals, and the totals are going to be represented by bars of equal width, and height also should be equal to 100. The bars what I am taking are going to be divided according to the percentage of components, and different subsections are going to be shaped properly, and an index whose describe the shades is provided. The percentage bars also equal in comparing the percentage components. So the percentage bar diagram is nothing but almost all similar to the previous diagram what I discussed. So in order to represent the magnitude should have two or more components, and the comparison of components are going to be expressed in terms of percentage of corresponding totals, and the totals are going to be represented by bars of equal width, and then height should also be 100. So example, I'm going to show the different extracurricular activity the students in nursing course based on the gender. So I want to represent how much percentage. So and like y-axis I'm taking percentage, and x-axis I'm taking for men and women. So in the men, so extracurricular activities for dance, so blue is representing dance, and TV red, and then sports yellow. So the number of men who are interested in dance should be around 5, and TV it should be around 45, and sports it should be 100. I want to represent it, not 100, 55. Like this I can able to represent the percentage bar diagram. Let me show another example. So the pure community, what is the percentage of obtaining fats in pure community and rich community? So for that I'm taking two things, pure and rich community on x-axis, and the percentage I'm taking on y-axis. So what I'm going to do is the percentage I'm going to representing here. So the blue, so blue is for percentage of carbohydrate, and percentage of energy obtained through protein is red, and through facts the percentage I want to find. So for that what I have to do, so my first pure, suppose the pure community and rich community. So within that I want to find uh, carbohydrate 10, protein 10, and then fat 80. So in case of rich community, it should be some 15, 30, and 55. So this is the table what we're having. So from this table I have to write. So what should be this pure community? So the pure community carbohydrate value is 10%, and protein 10%, and 80. So what should be total 90? So 100. Sorry. So make a bar of this, and then represent. So 10 for carbohydrate, so make a color blue, and again 10 for protein, make a color of red, and remaining total fat is 80. So similar in case of rich community, it should be around 15, right? So 15, make a mark of 15%, and remaining protein is 30% and 55%. So this should be comes under the single bar. That should be composite. And what should be the multiple bar diagram? So whenever there are two or more different comparable set of values, our multiple bar diagram is going to be drawn. So example, imports and exports, or like this. And the set of rectangles of equal width with equal height proportional to the value are going to be drawn, and the bars corresponding to the same unit are placed together adjacent to one another. So the bars corresponding to the same unit are going to be placed together adjacent to one another. The diagrams is shaded properly and is to be indexed, and an index is going to be provided. So when the multiple bar diagram is also be known as composite compound bar diagram. So whenever we're going to make more than two comparable set of items, then at the time I have to make use of this multiple bar. Here, the set of rectangle bars of equal width with height proportional to the value is going to be drawn here. The bars corresponding to the same unit are going to be placed together that should be adjacent to one another. The diagram what is shaded properly and is going to be indexed. See, suppose I want to find out the sales in north side, south side, east side and west side of India. So I am representing blue is for north, south is for red, green is for east, and purple is for west. So I want to say find out the sales. So what should be 2010, 11, 12 and 13. So this is the percentage of sales in north side, and this should be percentage of sales in south side, east side and west. So this should like this I can able to represent the compound bar diagram. Let's see the example. So similarly, the strength of student based on gender classification in nursing, I want to write same thing. So previous table. So in first BSc, second BSc, third BSc, and fourth BSc, I'm taking on x-axis, and this one is going to be taken as y-axis. So what should be the previous example? So within the single bar itself, I am representing this, right? So I can able to show in different bars means so 10 and 40 for girls. So 7 is boys and 38 is so 38 here, and this is for girls. And for 41 and 29. So in a single bar itself, I can able to show the representation. Suppose if I want to show it in the form of multiple bar, so like this I can able to represent it. So same thing here, I can able to show it. So make a bar of 10 that should be related to boys, and 40 is for the girls in first GSC who are interested, right? Similarly, gender classification I want to find. So how many number of boys are present in second PSC and number of girls in third PSC. So what is 7 is boys in there in second BSc, and 38 girls are there in second BSc, and third BSc 6, and then 41. And what should be this deviation bar diagram? So this is also one type of bar diagram, and this one is going to be useful for presenting the net quantities which have both positive and negative values, right? So it is going to be useful for presenting net quantities which have both positive and negative values. The positive deviations are going to be represented by bars above the baseline, and negative deviations are going to be represented through bars below the baseline. So some applications may have some positive deviations and some applications may have negative deviations. Normally this kind of deviations may come while seeing in Sensex. So Sensex is going to be Increasing means then the graph is moving up. If the negative values are coming, moving down, right? So same thing also here. So the deviation for budget expenditure. So AB. So that means the blue is going to be indicating the positive and downward bars above the below the baseline, right? So that should be negative deviations. So example, see this. So the variation from budget in different areas. So actual budget value, actual value and budget value and the variance how much it is. So how much variance I can obtain from administration, nursing, pharmacy, central supply and radiology. So here actual is 200, actual budget is 100, so positive I'm getting. So actually is 325, the budget proposed is 3,445, so that's when negative is coming. So actual is this, but proposing this negative I'm getting. So 45, but actual, the budget value 40, so 5% gain. So this one I can able to represent it. So this is the baseline. So administrator how much it is, how much variance 25. So I'm going to write it in upward, the baseline upward direction. So 20. So 20 means negative. So for nursing that is variance of minus decreasing. So I'm going to write the bar diagram in downward direction. So pharmacy again 5. Central 5. So that should be plus 5. So I'm going to write in upward direction. And radiology 10. So like this I can able to draw this deviation bar chart also. So this is another example, the percentage of sales and percentage of net profits I want to represent 1985 to 86. So this should be indicating. And one in 1986 to 87, so that maybe sales are 14% is increasing, but net profits are decreasing minus 20%. So similarly, 1987 to 88, so the 12% profit sales are obtaining and minus 10%. So that's why I'm drawing in downward direction. So what is the other kinds of diagrams what we're having for presenting the data? So that should be stem and leaf. So stem and leaf is nothing but a leaf plot, which is a quick way to organize the large amounts of data. So the stem and leaf plot is a quick way to organize the large amounts of data. And it is a special table where each data value is split into a leaf, usually the last digit, and a stem should be the other digit. So special table is going to maintain for this one. So each data value is going to be split into two types. So leaf and stem. So leaf means usually last digit and stem means other digits. So the stem values are going to be listed down and the values are going to be goes right and left from the step value. The stem is going to be used to group the scores and the leaf is going to indicate the individual scores within the group. So the stem values are going to be listed down and the stem is going to be used to group the scores and leaf is going to be indicates the individual scores within the group. So see this. So the example presents the pulse rate of 19 samples before and after intervention. So the pulse rate I'm going to calculating. So what should be the before and what should be the after. So in between this should be the before values and this should be the after values. So at the age of 6, so what should be pulse rate? 7, 8, 9, 10. So this is the baseline I fixed. So before it is 986, 988, like this. So once for age, the age, what will happen? So the before it is 8862, but after it becomes 6788. So I can able to find the pulse rate of 19 samples will be like this, right? So these are the various types of diagrams we are having for presenting the data. So we're having diagrams like bar diagram. So again, this bar will be of different types: simple bar, composite bar, multiple bar, deviation bar, percentage bar, and pie chart. So the pie diagram is the way of presenting the qualitative data, and the frequency of the groups are going to be represented in the form of circle, and the degree of angle is going to be denote the frequency and area of the sector, and it should also be gives compared to difference at a glance, and the angle is going to be calculated through the equation frequency by total frequency into 360. So for in order to make this pie diagram, so first make it as 2 percentage should be 100, and draw the circle, make a center, make a radius, and then make use of this protractor, and then draw the percentages. And the example what is shown here. And next one is bar diagram or bar chart I can able to call, and this should be consist of rectangle bars of equal width, but here the bars should be either represented in the horizontal way or vertical way, and this bars space in between them should also be equal, and the width of the bar should also be equal. So simple bar is going to be used when you are going to make comparison with a single characteristic, and these bars are going to be drawn on a common baseline with equal width between the two consecutive bars. So examples are this one. And next one is stacked or component of proportional bar. So that means within the bar itself I can able to make the composition, and similarly these items are going to be represented through rectangle bars of equal width only, and height should be proportional to magnitude. And next one is that percentage bar diagram. So within that bar itself I can able to make the classification into different partitions based on the percentage. So this percentage bar diagram able to represent whose magnitude should have more than 2 or more components, and the comparison of components is going to be expressed in the form of percentages of corresponding totals. Right, so within this bar itself I can make the percentages, make the segments based on the percentages. And multiple bar diagram, so multiple bar means, so this one is going to be used when you are going to make 2 or more different comparable set of values, and multiple bars are going to be drawn like imports and exports, and this set of rectangle bars are going to be also be same, maintain this equal width, and should be whose height should also be proportional to the value here. So like this I can able to make this multiple bars of a single item but use of different coloring. And next one is a deviation bar diagram. So this one is going to be used when presenting the net quantities which have both negative and positive and negative values. So all the positive deviations are going to be represented by bars above the line, and negative deviations are going to be represented by the bars below the baseline. So this should be the deviation bar diagram. So all the time I can able to represent the positive values above the baseline, and negative values or negative deviations is going to be drawn below the baseline. And the last one is the stem and leaf. So stem and leaf also the quick way to organize the large amount of data, and they should also maintain a special table where each data value is going to be split into 2 parts like leaf and then stem. So the leaf means usually going to represent the last digit, and stem means you can able to usually represent the other digits. So I want example what I said is pulse rate. So what is should be the pulse rate of 19 samples. So before and then after. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.